Hi everybody. We're going to start our 10.2 section, which is going to be all about arcs. But first we're going to do a quick review of 10.1 just to bring it into your brain cells. So in section 10.1 you learned the vocabulary of circles. Okay, you learned what a circle was, the center, the radius, the chord, the diameter, the secant, the tangent, and you learned about common tangents. So make sure that if you don't remember what those are, go back and look, okay, and try to memorize those. And you also learned how to determine if a line is tangent to a circle. Remember, if it's perpendicular to a radius, then the line is a tangent. And we also learned how to calculate the length of radii and tangent segments, and we had that ice cream cone theorem. So here we have the ice cream cone theorem, which says that when you have this point here that's outside the circle and you have two tangents from that line to the circle, then those tangents are going to be equal to each other. So if we needed to find x, we would set 3x plus 4 to 28 equal to 28 and solve for x. Okay, here we have some common tangents. So remember, they are tangents that touch both circles in one spot. Okay, and then here we have our radius here is 12, and this length here is 35, and we know that this is a right triangle because it's tangent and this is coming out from the radius. Okay, so this is going to be 90 degrees. So that means all those things that we can do with 90-degree triangles, in particular trigonometry and using the Pythagorean theorem, we can use for these triangles. And here are definitions: the chord, the radius, the diameter. The diameter is going to become very important today. We have down here a secant, the point of tangency, and also the tangent. Okay, so hopefully those are starting to get into your brain and you'll be really adept with them soon. Okay. So in section 10.2, sorry, you'll learn the vocabulary of arcs. There's always vocabulary. So yesterday was vocabulary of circles, today is vocabulary of arcs. How to find the measure of an arc, and how to tell if circles and arcs are congruent. So are two circles congruent and are two arcs congruent? Circles and arcs are never congruent to each other. Okay, so the vocabulary of arcs. What does it mean when we say a circle has 360 degrees? Okay, you've probably been saying that since about 4th grade, but what does it really mean? So if you think about it, when you have a length, a line, okay, you use what we call length to measure the line. So we can say that this line is, just say for instance, 2 inches, and that's a length. And so for straight lines, we start at a reference point, okay, and then we measure along the line, and we find that it's 2 inches, and we say that this is our length. Okay, but that doesn't work for curves. Okay, so for curves, okay, we don't use lengths like inches, okay, or feet or whatever. For curves, we measure with degrees. Okay, and again, we need a reference point, just like we had a reference point here for length. We need a reference point for degrees, and in a circle, okay, that's that center. So our reference point is the center. Okay, so what we need to find out is, what we want to find out is how long is a curve? How long is this curve that goes around this reference point? Okay, And so what we say is we divide that circle up into little pieces, which we call degrees. And so we can divide our circle up into all these little degrees. Okay? And it turns out that there's 360. We divide it up, so there's 360 degrees in the circle. So there's 360 of these little dots. And that's the standard. That was, I mean, years ago they could have divided it up into 50 pieces, 50 degrees, or they could have divided it up into 1,000, but they chose 360. And it turns out that that there's a lot of reason for that, but we won't go into it, and it's something that you'll learn when you get up into upper mathematics. So, but still, how do we measure? How long is that curve? So the way we do it is if we draw a radius between the part that we want to measure, the start of the part we want to measure, and the end of where we want to measure. So say we're going to measure this length right here, okay, of the curve. Then we need to count how many degrees are in there. And it turns out that the number of degrees that are in this line, okay, are the same as the number of degrees of that angle. So if this is a 30-degree angle, then we say this length is 30 degrees. Okay, so there's 30 little degrees points within those two lines. Okay, and that's what we mean when we say that a circle has 360 degrees. It means the number of degrees that we've divided the circle into, which by standard is 360 degrees, which was set up about 1,000 years ago. Okay, and we can measure this angle here to tell how many degrees are between those 2 points. Okay, so you could take a protractor and measure that angle, and you'd know what the length of that arc was. Okay, so if you need to replay this part, please go ahead and do it. It's theoretical, so you might need to hear it a couple times, okay, in order to get it. And as always, if you have questions, please ask. So we're going to continue with our vocabulary of arcs. So there's two kinds of arcs. There's a major arcs, and there are minor arcs. Now, minor arcs are less than 180 degrees, and we'll talk about what 180 degrees means in a minute, okay? And the minor arc, which is associated with this circle, is arc AB. See, it's a little arc. It's small. Okay, it's less than 180 degrees. The major arc is this guy all the way around here. Okay, and that we say is the major arc ADB. And we know the whole circle is 360 degrees. And so if we subtract 100, whatever the length is of this arc, okay, and the way we write that is the measure of arc AB, we're going to get the measure of arc ADB. We'll do more on that in a minute, okay. Now, a semicircle, okay, is defined by a diameter. And remember, a diameter goes directly across the circle, passes through the center, okay, starts at one edge of the circle, goes all the way to the other. That's the diameter, okay? And a semicircle, okay, basically divides the circle in half. So see, we have 1/2 here. A diameter cuts the circle in half. Okay, we have another half over here. Okay. So a semicircle is half of a circle. Okay, so semicircle is half of the circle. It's divided by the diameter. Okay, we're going to get onto that a little bit more. Next slide. Okay, so measuring arcs. So notice, very important, when you measure a minor arc, okay, so this 50 degrees, it's less than 180. It's less than 180, so it's a minor arc. Okay. And notice how we write that. We write the M for measure, okay, just like we did with an angle, and we write the A and the B, which are the two endpoints of the minor arc. And then we put a little arc over it. Okay, make sure your arcs look like an arc, okay, not a straight line, because AB with a straight line means the line or the line segment AB, and that's not what we're talking about. We're talking about an arc. So make sure that this little line here has a curve to it, okay? Those of you who like to write quickly, please be careful of that. So a minor arc is defined by its two endpoints, okay? And in this case, we're told that measure is equal to 50 degrees. So the measure of a minor arc, we write measure of AB with a curve is equal to 50 degrees. Okay. Now, major arc, change colors, measure of a major arc. So here is our major arc. Okay. And the way that you write a major arc is that you write the measure, okay, and to write a major arc you need 3 points. You need the starting point, okay, which is A. You need a point somewhere on the circle, so here's D. And then you need the end point, which is B. You have the measure of arc ADB, and again you have this curvy line over the 3 letters. So that's how you tell. If you're just given like MADB in a problem, you know that that is a major arc. It's going to be greater than 180 degrees. If you're just given 2 letters for an arc, then you know that it's a minor arc. Okay? And the way we calculate the measure of the major arc is that we take the whole circle, okay, and then we subtract the minor arc, which is 50 degrees, and that's going to be equal to 310 degrees. So the measure of our major arc here is 310 degrees. Okay. So the measure of a semicircle, okay, so remember a semicircle is formed by the diameter. Diameter touches both sides of the circle and goes through the center, and the semicircle is half. So we want this distance. So it's half of the circle. So it makes sense that the measure of this semicircle, okay, is 360 degrees divided by 2 is equal to 180 degrees. So the measure of a semicircle is always going to be equal to 180 degrees, no matter how big your circle is. Okay, and we'll get into that a little bit later. Okay, so let's do a little bit of practice. Okay, so we're going to find the measure of each arc of circle P where RT is the diameter. So here's our diameter, RT. Okay, so this is asking for RS. So I'll change colors. So let's look at RS. Okay, and we're given the measure of RS. And so measure of RS, the way it's written here, is equal to the measure of the angle RPS which is 110 degrees, just like it's written there. Okay, B. So RTS okay, so first thing we have to notice that RTS is a major arc because it has the 3 letters, okay? And we need to take a look at, change colors again, okay? So here my starting point is R, but which way do I go? Okay, do I go this way or do I go this way? Okay, this way or this way around the circle. So these 3 letters give me a clue because they are in order. So I have to go from R to T to S. So R to T to S. Okay, and this is my major arc RTS. And so how am I going to find that? I'm going to take 360 degrees, okay, the measure of my circle, the total. I'm going to subtract that minor arc, 110 degrees is equal to 250 degrees. Okay, pretty easy. Okay, C, let's look at arc RST, and I'm going to erase this so it's easier to see. So I'm looking for RST. So RST is a major arc, okay, because it has the 3 letters, okay, and we have to go in the right order. So we start at R, we go to S, and then we go to T. So it's this arc right here. Now, we look at that and we say, aha, RPT, the line RPT is a diameter. And actually that's given up there. So if RPT is a diameter, then what does this measure have to be? And if you remember from the previous slides, okay, the measure of a semicircle, doesn't matter how big the circle is, how small the circle is, the measure of the semicircle is always going to be 180 degrees. Okay? So, of course, we can do all sorts of fun things with these. We can put in variables, make you calculate different things, which we will do. But this is your basics. These are your basics. So please make sure that you understand all of this. Okay. So this is a little bit of application. So this is called a circle graph, and many of you may have seen this already. But the circle represents the whole. So if we look at, this is a survey, so a recent survey asked teenagers if they would rather meet a famous musician, athlete, actor, inventor, or some other person. The results are shown in the circle graph. So what the circle represents is all the teenagers they asked. And so what the circle graph is telling us, that of all the teenagers they asked, 108% of them would rather meet a musician, okay? 83% would like to meet an athlete, 61% would like to meet others, 79% actor, and 29% inventor. I think that's sad because inventors are really cool people. But anyway, I digress. So, you're asked to find the indicated arc measures. So remember, the measures of the arc are equal to the angles, okay, of the pieces of that pie, the pieces of that circle. So let's look at the measure of arc AC. Okay, I'm going to erase some of this stuff. Okay. So AC. Now, decision point. So measure of AC, what kind of arc is that? Is it major or minor? Well, we know it's minor because it only has 2 letters. So if we start at C, we start at A, and we're going to C, okay, if I go this way, that's obviously more than 180 degrees. That's more than a semicircle, okay? So that is not the way to go, okay? The way to go, because it's a minor arc, is this way because it's under 180 degrees, okay? So the measure of angle of, arc AC is equal to this measure, the 29 degrees, plus this measure, which is 108 degrees. Okay, so 908 is 17, 137 degrees. Okay, so I'm going to erase this, change colors. Okay, B is measure of ACD. Okay, first thing we notice, it's a major arc. Okay, so we're going to start at A. We're going to go to D. So we can't go this way because that's less than 180 degrees from A to D, so we have to go this way. We don't want to do that. Okay, so all you do is you add up all those angle measures. So you're equal to 29 plus 108 plus 83. Okay, measuring, I think that's 220. And 311, yeah. It's 220 degrees. Okay. So, let's erase that one. Okay, C is measure angle ADC. Okay, now here's A, here's D, here's C, okay, and this is obviously a major. Sorry about the handwriting there. So from A to D to C, it's equal to 79 degrees plus 61 degrees, DC plus 83 degrees, and I believe that's 223 degrees. Okay, so I'm going to put D over here. Okay, so D. Okay, measure of EBD, arc DB is equal to, okay, here we know it's a major arc, so it has the 3 letters, okay, and our starting point is E, our next point is B, and we're going to go all the way around to D. Okay, it's almost the whole circle. So we're going to add 79 plus 29 degrees plus 108 degrees plus 83 degrees. Okay, and that's all going to be equal to 299 degrees. Okay. So, and now, okay, if we look at this, just to check ourselves, if we look at this EBD, okay, and if we did our calculations right, we could add 61 degrees to that, and we should come up with the whole circle, which would be 360. So let's check. 10, carry 260, carry 360 degrees, right. So we know that we did our calculations right, and 299 degrees is correct. Okay, so please feel free to watch this part again if you need to, and if not, we'll go on to the last slide. Oh, that's not right. Okay, now this has to do with circles and arcs being congruent. Okay, remember, it means that they're equal to each other, okay, or they're the same. So two circles are congruent if they have the same radius. Okay, and also the same diameter, but the basic definition is that they have the same radius. Okay, and that's for circles. Now, two arcs are congruent, and they have to satisfy two requirements. One is that they have the same measure. Okay, so the number of degrees is the same, and number two, the second criteria is they are arcs of the same circle or congruent circles. So their measure is the same, and they're either arcs of the same circle or congruent circles. Okay, so let's look at some examples. So here, these two arcs, CD and EF, okay, they have the same measure. Okay, the question is whether or not the arcs, the red arcs, are congruent. So they do have the same measure, so they meet that same requirement, or that first requirement. And then the second requirement, that they are either arcs of the same circle or congruent circles. They are obviously on the same circle. So yes, the arcs are congruent. Let's look at B, and I'll change colors just to be clear. Okay, so we're looking at this TU here, and we're looking at RS, and we're trying to figure out if they're congruent. So let's look at the first criteria. So first criteria, okay, they both have the same measure. They're both 90 degrees. So they meet that criteria. Okay, let's look at the second one. Okay, but are they arcs of the same circle? Change colors. Is this circle the same as this circle? Okay, are their radii the same? Okay, is this radius equal to this radius? I'd say no. Okay, so they are not same circle. So the answer is no. Okay, arcs are not congruent. Okay, so let's look at C. So let's look at, okay, so we're looking at VX and YZ. Now these are two circles. Okay, they're two separate circles. So we'll look at our two criteria. Okay, do they have the same measure? Yeah, this one's 95, this one's 95. So yeah, they got the same measure. And two, are they the same circle? No, there's two different circles. Okay, now are they congruent? Well, how do we know if a circle is congruent? Okay, a circle is congruent if they have the same radius. So looky here. Look at this radius is marked with this sign, and this radius is marked with the same sign. So radii are the same, and so circles are congruent, which means yes, the arcs are congruent. Okay, and again, watch this part again if you need to review that. But with this knowledge, you should be able to go on and do the homework. And as always, ask questions if you need to.